Hi students, so today we will discuss kinetic theory of gases part 2. I already made part 1, please watch the part 1 and come to the part 2. Then, so here, there we studied fully the basics related to the gases. No? Here, so we will study what is the kinetic theory and the derivations of this one. No? We will not derive, so derivations of this and RMS speed, all this one, no? We will try to study on this one. No? So here to explain how these gases is present, therefore what will be the behavior, how the pressure is exerted by the gas now, therefore how the velocity of the gas depends on what factors now. So kinetic energy of the gas, how to calculate, internal energy of the gas, how to calculate. No, first of all you should know what is this gas is made up of. So therefore lot of assumptions is made. No, so what are that assumptions? No, that assumptions is made is not in the kinetic theory of gases. So according to this kinetic theory of gases, no, so the gas, okay, you know the basics of the gas. Now it will occupies the volume of the container, does not have any fixed volume, like that. Okay, so this is inside, there is a gas is there now. So this gas contains, so one small tiny particles. No, these tiny particles we'll call it as like a molecules, right? So these are molecules. So if one type of gas is there, all the molecules are in the same shape and same everything onto this, or no? So but it will be compared to from one gas to another gas. So these molecules will be different, right? So these molecules are exactly like a spheres. So therefore mostly rigid. So very strong. No? Therefore they are mostly highly elastic, perfectly elastic. So these are the gas molecules, no, and these gas molecules are separated very far distance, no, from one molecule to another molecule. These molecules are very tiny actually. Tiny means very small. Therefore the size of this one is around 10 to the power of minus 10. So in the order of 10 to the power of minus 9 to 10 to the power of minus 10. Therefore the size of the molecules, it will be in this order now. As because of due to their tiny, so therefore this one molecule and another molecule are very far away onto this one. Therefore they are mostly very far away onto this, and as they are very far away and this mass is also very small, the force between them almost it will be equal to 0, and the gravitational force between them is also 0, and potential energy between them it will be 0. Therefore there is no potential energy associated with these molecules onto this one. And these molecules will move in a different directions, no, in a random motion, no. So one, but while it will go in the form of like a straight line. So therefore when what it will do, while it is going, it will collide with another molecule, then changes its direction, but it will go in the straight line. Therefore so like this, these molecules will go in a different random directions, no. So therefore here what will be the average speed of the molecules now? Therefore what is the speed now? Speed ranges now. Speed ranges will be 0 to maximum speed, it will be there like we can treat it as like infinity, but infinity speed will not possible. Maximum speeds will be there. All possible speeds are there, no, but one most of the molecules will have most probable speed now. That means so most of the molecules will have more same speed onto this one. That is said to be most probable speed now, right? So therefore what will be the average speed of this gas now? What is the average speed of this total gas molecules now? Average speed of the gas molecules, it is said to be 0. Why it is 0? So definitely there is a large number of molecules will be there, no. So one molecule is going with one speed, so definitely there will exist one more molecule, no, which is going in the other speed opposite to the direction, no. Total net average it will becomes to the 0, right? So even if your fan is not there, nothing is there in our room, so we cannot feel that is like a air is present. Why? Because air molecules, the total average speed of our air molecules will be 0. Therefore now as it is, but every molecule is having some amount of energy, no. So that is said to be like a kinetic energy of each molecule. What is the kinetic energy of each molecule? No, that is nothing but a half mv square. But total kinetic energy if you want to calculate, no, so you should not take it as average speed, no, you have to take RMS speed. So what is this RMS speed now? RMS speed means, so RMS means root mean square. root mean square. Why we have to write it now root mean square? See, average speed means one speed it will be there. So one more speed it will be having, one more gas molecule will be having another one more, it is same speed in opposite direction. Therefore, net force, net velocity will becomes to the 0 onto this. So then, in order to overcome this one, no? So what we are going to use it now, we will take it as RMS speed. That is root. So mean means average. Squares means, so we have to take it as V1 square plus V2 square plus V3 square, so on. Therefore, Vn square. So why we are squaring now? Even there is a negative value is there now, therefore whole square now, it will make it as positive. So we are squared. We are taking the average of this one now. We already squared now, we want to remove it now, that's why you can write it as like a RMS speed of this one now. So this RMS speed only we can use it for our kinetic energy of the gas. So what is the kinetic energy of the gas now? So kinetic energy of the gas now, so you can write it as like a half m, therefore V RMS, so therefore whole square. Kinetic energy of each molecule we can rewrite it like a half mv square. So this it will be the kinetic energy. What will be the potential energy of the gas molecules now? So potential, because they are far away onto this, no, force between them is 0. So they will go in the freely in the random directions, no, but while going it will go in the form of a straight line. So but potential energy, so force between them is 0, potential energy between them molecules, no, it is 0. So it will be having only kinetic energy. So that's why, so this kinetic energy only we will call it as like a internal energy of the gas. Internal energy of gas, right? So internal energy of the gas is nothing but what? Total kinetic energy of the gas, right? So these molecules, right, while it is going, how they are going to exert the pressure now? This is very important concept, no? So how they are going to exert the pressure now? So therefore these molecules will go and it will collide with a one molecule to another molecule, right? Like a lot of collisions will take place now. So also it will collide with the walls of a container. So suppose these molecules, some one molecule is there, no? So this molecule, so what will happen now? It will go and it will collide with one speed, no? And it will be rebound back with the same speed. It will rebound back with the same speed. So in this collision, there is no loss of energy. That means it can understand that it is said to be like a elastic collisions. So what is elastic collision? What about the collisions? No? Also I did one separate video on the collisions. No? Please watch that. So what are elastic collisions? No? Elastic collisions, therefore there is no loss of energy of this one now, right? So elastic collision will take place mostly, so only the gases onto this one, no? It is assumed that. So this molecule will go and it will hit and it will rebound back onto this one, right? So no energy loss, no energy loss, right? So in the elastic collision. So but when a ball is coming and hitting onto this one and rebounding back with the same speed, no, so it will create change in momentum. What is the change in momentum? Change in momentum. So what you can write now? Change in momentum. Change in momentum. What is change in momentum now? So final momentum minus initial momentum. How it will be? Change in momentum takes place now. What is the formula? This side it is your initial momentum mv and rebounding back one, no? But it is a vector quantity, no? Mv and mv you have to add it. Most of the students they will think that, so this side it is one particle is going, this side it is mv initial momentum, so final momentum is also mv. Most of the students they will think that momentum is 0. No, momentum is not 0 because it is a vector quantity. So this is your initial momentum is toward this side, so final momentum is toward this side now. So therefore if you consider this is your direction now, so this is positive, this is negative, therefore it should be added up. So this also I explained in our collisions onto this one, no? So please watch it. So therefore 2mv, this is a change in momentum. Okay, so change in momentum, so if this change in momentum takes place by certain amount of time, no, so this change in momentum by time, so therefore by time, so we will call it as like a force. Yes, and force is nothing but what? What is the Newton's second law? Second law is nothing but a rate of change in momentum. So change in momentum by time. Okay, therefore these molecules are exerting the force. Like that hundreds of molecules are coming and exerting the hitting to the walls of a container. So it is going to exert the force. Force upon to this area. So force upon to this area. So this area. So we'll call it as like a pressure. So divided by this area. So divided by this area. So this will exert the pressure on this. Clear? So how the pressure is exerting now is because of due to the collisions. If more collisions are takes place now, so therefore what will happen now? More amount of pressure it will be exerts onto this. Clear? So this pressure we can calculate for monoatomic gas no. So this pressure by kinetic theory of gases exactly nothing is there most of the times no, you have to select it this one no. So they will be having different speeds along the x-axis, along the y-axis, along the z-axis. These all the things no we have to take into consideration, but not required for your derivation onto this one no. So but once in JEE mains and advanced no, these questions are only asked no. Please go through it onto this, right? Now based on the kinetic theory of gases KTG, so we calculated therefore pressure. So for monoatomic gas, clearly monoatomic gas, monoatomic means what? It's like a atomic gas, like a noble gases, like helium gas, neon gas, no, only one atom it will be there, no, mono means single. So for monoatomic gas, no, it is derived that pressure, this is what a pressure. So pressure we can rewrite it as like a 1 by 3, so rho is nothing but a density, so into Vrms square. This is your important derivation, so which is given from the KTG, right? So we can derive it now, we can get it your answer. So here pressure it will be equal to 1 by 3 density is nothing but what? Mass of the gas by volume, so into Vrms square. Clear? Now here so we can rewrite it as pressure into volume, or in terms of kinetic energy. Kinetic energy, what is the formula here no? Kinetic energy is half total mass of this one no, into Vrms square. If you want to write down volume by volume, so therefore here 2 is there, therefore 3 is there no. What I will do? I will multiply with 2 and I will divide with 2. So what I will get it now? Here I will multiply with 2, so I will divide with 2, therefore 2 by 3, this I can take it no. Pressure is equals to therefore 2 by 3, 1 by 2, this all this one no, this is nothing but a kinetic energy per unit volume. So this formula itself it is asked in the examination, or you can write down pressure into volume is equals to 2 by 3 into kinetic energy of the gas. This is one important derivation, so which was given by this kinetic theory no. But this all the derivations no is done for monoatomic. So for what is the diatomic and all this no, slowly we will study. So what will be formulas for diatomic and all this no, clear? So here most important one no, we will write down RMS speed. What is RMS speed formula here? RMS speed formula. So okay, one more thing no, we can write it as, so please keep in mind this one no, we will write it as RMS speed, Vrms, very important. Pressure is equals to how much now? 1 by 3 rho into Vrms square now. Therefore here we can write it as Vrms, it will be equal to root of 3p by rho. So 3p by rho, this is your RMS speed onto this one. Similarly we can write it as RMS speed, it will be equal to 3p density of this one no, mass of the gas into volume. But we know pressure into volume is equals to nRT, or pressure into volume is equals to it is nKT. nKT, clear? So therefore Vrms it will be equal to 3 PV is nothing but a nRT by total mass of the gas. Number of moles, how to write it now? Mass of the gas by gram molecular weight no. So Vrms it will be equal to 3 RT by gram molecular weight of the gas now. So even we can write down therefore Vrms it will be equal to 3, so nKT by it will be m. Clear? So this is your RMS speed so of our gas molecule, right? So this RMS speed, can you tell me how it is depends upon the temperature now? RMS speed is directly proportional to the square root of absolute temperature. That means if temperature increases, RMS speed will increase. So if temperature decreases, RMS speed it will be decreases now. So therefore here RMS speed it is inversely proportional to square root of gram molecular weight. That means heavier gas molecule is there. Heavier gas molecule means what? Like a nitrogen gas molecule is there no. So compared to hydrogen gas molecule, nitrogen gas molecule is slightly heavier onto this one no. So heavier molecules, so will be having less RMS speed. So lower molecules, so like lighter molecules will be having higher RMS speed. So one more important formula, so we can rewrite it as, so here RMS speed, how it is depends upon the pressure. So we know PV is equals to NKT. So therefore here we can write down this is PV is equals to N is nothing but a mass of the gas by gram molecular weight into RT. So here you can take it as this downward M by V density taken here now, pressure by density. So pressure by density is nothing but a RT by gram molecular weight. So pressure by density is always constant for a given one. No? If pressure increases, density also increases. If you compress the gas, no, what will happen now? Density will increase because Y volume is decreasing now. If pressure increases, density also increases. Pressure decreases, density also decreases. This ratio is always constant. So that's why RMS speed is independent of pressure. Right? So very, very important for a given gas. If the same gas is there, no, so same gas, therefore if you are increasing the pressure, therefore RMS speed will not change. When you compare from one gas of higher density to lower density, so therefore from one gas to another gas, no, so what will happen now? Therefore here RMS speed is inversely proportional to the square root of density. Therefore higher density gas, no, so will have less RMS speed, and lower density gas, no, will be having higher RMS speed. That means lighter gas will diffuse faster, heavier gas will diffuse later. That's why we will call it as like a Gram's law of diffusion is related to this concept only, right? Rate of diffusion, so is nothing but like a RMS speed onto this. Clear? So in this way, so the RMS speed we can calculate it now. Clear? So therefore we can do one question here now, very simple question now. So let us do one question. So we can calculate RMS speed of a helium, so at 27 degrees centigrade, so divided by RMS speed of nitrogen, so at 127 degrees centigrade. So this ratio we want to calculate it now. How RMS speed depends upon this one now? RMS speed depends upon the temperature and inversely proportional to the gram molecular weight. See, we already studied now. So RMS speed is nothing but a 3 RT by M. So therefore directly proportional to T, inversely proportional to this one now. So what you can write it now? Directly proportional to T. So temperature of the helium by temperature of your nitrogen into, therefore inversely proportional gram molecular weight of nitrogen by gram molecular weight of helium. Clear? So we know that temperature of the helium is how much now? 27 degrees centigrade. Don't use Celsius, no, you have to use always in Kelvins, right? So therefore here Kelvins 27 plus 273 means it is nothing but 300. So 127 is nothing but 400. Helium gram molecular weight is nothing but 4. So one nitrogen atom is 14, so twice that is nothing but 28. So therefore 2 zeros, therefore it will be 1. So therefore here root 3 by 28. This it will be your answer on this one. Clear? Like this you can calculate it, no, RMS speeds of the different things, right? Now we will calculate the kinetic energy. So very important, kinetic energy of gas. So this is most important, very important. So this also will do for monoatomic, no, then we'll go for diatomic and all this one. No. So what is the kinetic energy? We already written, no. So therefore here RMS speed, what is RMS speed now? Directly proportional to 3 RT by therefore M. So R3, therefore 3 NKT by M. So therefore here what you can write it now? So RMS speed, so or kinetic energy half mv square. What is the kinetic energy formula? Therefore half m into v RMS square now. So just multiply this one, 1 by 2 m into therefore n by this one also you can write down nRT. So 3 by 3 nRT by total mass of this one, right? So therefore whole square, no, 3 n r t by m, therefore you can write down, so 3 by 2 n r t, so this it will be the kinetic energy for monoatomic. So similarly substitute this one, no, so kinetic energy you can rewrite it as therefore 3 by 2 n kt, very important, no, for monoatomic gases, because we derived all these equations for monoatomic gases, no. So here kinetic energy for monoatomic gas, it is given as 3 by 2 nRT. This is in terms of number of moles and you know R value. So this is the kinetic energy 3 by 2 nKT. This is in terms of number of molecules or number of atoms in terms of a Boltzmann constant. Observe this now, kinetic energy is purely depends upon the only on the temperature and it does not depend upon any other parameter. No. Like one surprising result, no, suppose one hydrogen gas is there and one nitrogen gas is there, if they are at same temperature, therefore their kinetic energy it will be the same only, does not depend upon the different material onto this one. Kinetic energy purely related to the temperature of this one. Clear? So here we defined it as like a absolute zero. So therefore what at 0 Kelvin, so what will happen now? Kinetic energy of the gas molecule will becomes to the zero. Kinetic energy becomes to the zero. So potential energy, however, it is zero. Kinetic energy zero means what will happen now? Molecules will not move. Will not move means they will not be separated now. Kinetic energy is dies off. So total it will comes to the zero. Therefore at 0 Kelvin, therefore gas it will be the zero only. Therefore nothing, gas will not be present onto this one now. So that's why it is impossible to live at minus 273 degrees centigrade. Live means, so at impossible, therefore there is gas will not be present onto this one, no, or atmospheric pressure. Atmosphere will not be present at 0 Kelvin. So that's why we can call it as like a absolute zero. Absolute zero we will call it as, no. Therefore at 0 Kelvin the gases will be absolute zero. Absolute zero means pressure is zero, volume is zero, speed is zero, kinetic energy is zero, total internal energy will be zero. So that's why we will call it as like a absolute zero onto this. And this is the kinetic energy for so different molecules, but this formula is for only for monoatomic gases now. Diatomic, right, and triatomic, polyatomic, no. Therefore these formulas it will be different onto this. Right. So till now we studied kinetic theory of gases for kinetic energy of a gas molecule for monoatomic. So how we will write down for diatomic and all this one, no? So first of all you should know, so here law of equipartition of energy, no. Before that we should know like a degrees of freedom. What is the degrees of freedom now? Very important, no, degrees of freedom. So in the name itself is there, in how many ways therefore the molecule will be able to move freely. So therefore for monoatomic gases means what? Like a neon gas, helium gas are then one atomic. So it can move in which direction now? It can go along x-axis, y-axis and z-axis. So how many degrees of freedom will be there now? Degrees of freedom is 3. So these 3 are nothing but a translational only. Translational degrees of freedom. Clear? So therefore degrees of freedom are 3 only. So now we cannot able to see the rotation, no, because it will passes through the molecule will passes through the axis of rotation. So rotation will be 0 onto this. Next one, diatomic. What is diatomic now? You might have seen H2, N2, O2 like that. So these all are the diatomic molecules. How that structure will be there now? It will be in the form of like a linear structure. Therefore it's like this. So this molecule can go. So here all it can go in the 3 translational. So this is translational. And also rotational will be there. This it will be along the right y-axis. No, it can be able to rotate like this. It will be rotated now. So like this it will be rotated. But along this now, therefore these are passing through along the axis of rotation, does not have any rotation now. Therefore it will be having 2 rotational now. Clear? Vibrational we are not taking consideration. No. Next one, these 2 are enough for NEET level. Okay. So if you go for IIT-ADVANCE and all this one, no? So triatomic. In this one now, triatomic. So therefore here linear and non-linear structures also will be there. So if you take it for linear means what? The shape it will be like this. Therefore here like this, right? So linear structure, therefore again it will be there. So 3 plus 2, therefore translational and 2 rotational. Yes or no? So for non-linear, so we can take it as like a vibrational also. Therefore for non-linear, so 3 translational plus 3 rotational now. Therefore 3 rotational. So this it will be your degrees of freedom for a triatomic. Only translational and rotational we take it now. Monoatomic, diatomic. Okay. Okay. Why we studied this one now? So to study this, so we require here law of equipartition of energy. What is this law of equipartition of energy? Okay, if you don't know, just read the statement. Law of equipartition of energy. That means energy. Equipartition means what? Equally divided. Partition means dividing. No. So energy we have to divide equally. Among whom? No? Among the degrees of freedom. That's all. Therefore, so what will be the statement here? No? Law of equipartition of energy. Energy of a gas molecule. So it has to divide equally into their degrees of freedom now. So that's why monoatomic gas, what we written now? So kinetic energy we written as 3 by 2. So therefore RT or KT. Okay, 3 by 2 KT we written now, right? We'll write it. Anything you can write it now, KT. So why 3 here now? Because it is having 3 translational now. Therefore kinetic energy, so therefore 1 by 2 KT. So this is along the x-axis plus 1 by 2 KT along the y-axis, 1 by 2 KT along the z-axis. So this all are at same temperature onto this one now. So that's why therefore we can write it as this one now. Similarly, therefore here for diatomic molecule, so diatomic, how to write it now? Kinetic energy, it should be equal to therefore 5 by 2 KT. Why 5 by 2 KT now for one molecule, right? So 5 by 2 KT means 3 translational and 2 rotational now. So generally what we can write it now from the law of equipartition of energy. So generally we can write down here 3 means degrees of freedom, here 5 means degrees of freedom, like that. So F by 2, so therefore nRT, it is number of moles, RK kinetic energy will be equal to F by 2 nKT. These are the kinetic energy of any gas. This is only very important. No, we can write it for any type of a gas. What is this one? No, so kinetic energy, its degrees of freedom, like monoatomic means degrees of freedom is 3. So if they may ask you, therefore only rotational kinetic and rotational energy. What is the rotational energy? So for monoatomic, no rotation. No, diatomic, only 2 rotational will be there. Here total rotational means 2 by 2 nRT, like that. If they are asking full total energy, therefore 5 by 2 nRT or 5 by 2 nKT. So like that, only rotational, only translational also they may ask you, or total also they may ask you. So ultimately you have to write this formula. So if they are asking what is the total internal energy of the gases now, total internal energy of the gas is nothing but a kinetic energy of a gas only. Clear? So what is the total internal energy formula? So internal energy formula is this kinetic energy of a gas molecule. Clear? So practice this type of concepts. No? So we'll do like one video. So problems related to this, different models. So we'll try, we'll come with one more video. So be thorough onto this one. And next part and third part also will be there. So we'll study degrees of, mean free path and specific heats onto this one, and mixture of the gases also we will discuss in the next part. So all this one, we can combinedly we get it as like a one numerical part. No? So we'll solve all the possible problems. No? Stay tuned to my channel. No? So thank you. Please subscribe to my channel. Thank you for watching.